a couple of mods here that I designed myself for your download pleasure. And that is going to be the hot end cover. This is the Dragon hot end. This one will be available on Thingiverse in my mini factory in the pack below, as well as the Iron Man bed leveling wheels that are the same as the extruder, the V-slot side mounted spool holder, and a couple of other parts. This case here and the adjustable piece underneath it are not mine. You'll hear more on those in a couple of minutes, but basically these are the pieces that we're replacing here. This one is actually a printed mod as well, but I wasn't a big fan of that side mount, so I knocked out my own, and I think I like that a little bit better. So all of these mods will be available for download. I will have a singular pack that includes the SD slot card holder, the V-mounted side spool holder, 2 hot ends including the Dragon, and a blank hot end, as well as these wheels here. So all of that will be available for download for free at the link below, and then I will also have 2 other links. One of them is going to be to the case, and the other is going to be to this adjustable piece here. And thank you to the creators of those 2 pieces, and we will speak more about that in just a minute. Let's jump right into this video. This is 3D Thursday, and we're going to get into it right now. The Technivorous channel is brought to you by these fine Patreon supporters. If you'd like to check us out on Patreon, pop over to www.patreon.com/Technivorous. That's TECHNIVOROUS. Here, we do our best to stay up to date on the latest and greatest in 3D printing and tech, and keep you informed on the latest developments in these sectors. So, if you're interested in getting updates on 3D printing or technology such as programming, robotics, artificial intelligence, and things of that nature, make sure you hit that subscribe button down below, leave a like on this video, and comment about what you'd like to see in the future, because we make these videos for you. Alright, so welcome back, folks. As you can see, this is my Creality Ender 3 V2, and today we're going to be adding several mods to this beast. So a couple of them are pretty simple. They'll slide right over the V-slot. A couple of them require screws and T-slot nuts, which are already attached to the machine. And there are a couple of them that you're going to actually need some glarks for. So this isn't really a necessary part for the screen cover that we're going to show you here in a minute, but it will be necessary to get the hot end to fit on properly. So this hot end cover that you're seeing right here is a special design. This was my first one to see if the dimensions were right, so I punched that 3V2 hole in there, basically just to ensure that it had a port for the fan. Don't think I'm going to be releasing this cover itself, but it's a possibility. I think if you want to see me release that, go ahead, leave a like on this video, and if I get 100 likes, I will release that file. But I do have some other files that are going to be available, and they'll be available for free for download today. I'll have a link down below, and one of them is this hot end cover here. Now this is a cross between the Dragon from the Ender machine and the Dragon from one of the teams in Ender's Game, the old school, the novel. So I thought it was pretty cool. It fits pretty well. I did make a minor adjustment in the length of this piece right here. Between this iteration and this iteration, this one does fit a little bit better because this is longer, but as you can see, this is pretty sturdy and stable. So I'm not going to change this out because I like my 3v2 version, but I will tell you that these 3 holes here, 1, 2, and 3, are for the fan, and they don't need glarks. They have holes. The screws will go right into there. There's actually only 2 screws in the fan, and they'll be the 2 diagonally across from each other. A little support left in there still. The glarks are going to go here, here, and here. And this one is attached to the part cooling fan, which slides in this side here. And these 2 are how it actually mounts to the plate here and here. So pretty self-explanatory. I might do an in-depth video on how to do that a little bit later on, but for now, we're going to stick to doing the mods that I have here. And I wanted to show you this. This was a pretty cool, this is a side-mounted spool holder. The spool holder goes here, and it worked pretty well. I wasn't a fan of the screw-in style. So what I did is I went back and mocked up this guy. So this is my side-mounted spool holder. The spool is in there. This design is based on Chuck Hellebeck's design, which he got from somebody else, I believe. I'll have to get the name of the guy. But I did completely redo this one from the ground up, put these triangles in to save a little bit of printing. So we're going to go ahead and slide this on first because as you can see I already popped off my back cover here. So we'll put this guy on first. And that'll be our first mod. Okay. Fairly simple. Put the cover back on. Then we are going to slide it back a little bit so we have room for the spool in between here and the extruder. If I can get it to go in, there we go. Okay, so our spool is now going to sit right here and feed directly into the extruder. So that's pretty nice. I'd like to get a little bit better view of this guy here. You can kind of see it back there. I chose to go with this blue color. And I apologize for the shadow in the background right now. I hope you guys can see okay. I chose to go with this blue color because it matches the accents on the machine already. So what else do we have here for mods? Well, we've got a few other things. I have some denser springs. Now, at first, I was going to put these on because traditionally the Ender 3 Pro was a little bit weak in the springs, and they recommended those yellow ones for an upgrade. However, I will tell you that since I've had this machine, I leveled the bed once and only once. So these springs are pretty sturdy. I will, however, in a minute show you how to change them because we're going to be inserting Glarks into our leveling wheels as well. And these guys are modeled after the extruder knob up here. They're the exact same design. Let's jump back one more time. Fix my camera a little bit. Okay. And we're going to put on this guy. So this is pretty simple. This is an SD card holder, and it does slide into the V-slot rail on the top. And actually, this guy will fit any printer that is a 2020 V-slot rail. So we're going to go ahead and pop this end cap off here. And remember how I said these two go on super easy. It's just basically sliding it in. And I gave it a little extra height there to get over those screws. And there you go. All of my cards all lined up on the top. Now, with the original Ender 3 and the Ender 3 Pro, I did always print a tool holder, but now we have this handy drawer that comes stock on this machine. So I'm not doing a tool holder on this guy, although I will be going back later, and I think we're going to redo this knob, if not the whole drawer. And you can see that a little bit better there. Next, we have a couple of mods that are going to go on the right side. So I'm going to swing around. We'll block the light here for a second. And we're going to come through and we'll hook this guy up over here. So this is the LCD screen. And it comes out pretty easy. Just pops out like that. And then we're going to remove these 4 screws from the back, these machine screws. And whether or not we want to put them back in is debatable. This part also has position spots for Glarks. You can see that I marked them. That's what that little pen mark is. But it fits really, really well and also clips onto this back. So don't think it's absolutely necessary to use the Glarks and screw it in. So let's check, and I will show you what I'm talking about as far as how well it fits. So we're going to get all these guys out here. Pretty simple. Now, other than the springs, all of these mods are aesthetic. They're just for looks. They're not going to affect the performance or running of the machine. Other than maybe the side-mounted spool, depending on what type of filament you're using, that can actually be really handy. So let's go ahead. Oh, we want to take the knob off first. We'll set that here. We are going to keep that knob. That nice black accent will look good against... There we go. So we're going to pull this piece out. Okay. And we're going to reuse this piece because it has those nice clips on there. So if you look here, there are clips for tabs. There aren't actually tabs on here, but it does fit really well. So what we're going to do is we're going to carefully pull these tabs back. Now, this is pretty simple itself. It's just going to pop right on. And it fits really, really well into these compartments here. So like I said, once the back is reattached, you don't really need those machine screws in there. I will eventually go back, put the Glarks in, and pop them back in, but that's pretty sturdy. So we'll put the control knob back on as well. And make sure everything's snug here. There we go. Get it to pop into place, and then I don't have to worry about it. So, as you can see, this piece goes right here. I do, however, have a slight issue with the angle of this. So, what I want is something that's a little bit more vertical and maybe adjustable. So, I also have a mod for that. So, that's this guy here. This was made by a gentleman named Pugwash. You can meet him in our Discord, and I will make sure to have a link to this as well. So these two parts are the only two parts that I did not make. And I will make sure that there are Thingiverse links to them down below. But yeah, these aren't going to be included in the actual pack that you'll see, the free download pack. So in order to put this on, we need to remove this piece right here. So let's turn the printer a little bit. Go back to our old Allen key. And this one is held on by 3 machine screws. And we're going to replace it with just 2 machine screws. And that'll be fine. And I'll show you how this works here. As soon as we get it on, if I can get, there we go. All right. Nice thing about the T-slot locking nuts is that I don't need to unscrew the screw all the way to get the part off. I can unscrew it so the nut's loose, and then wiggle it out, and then it comes off a lot quicker with my fingers. So there we go. There is 1, 2, and 3. We're going to actually toss one of those in the drawer so we don't lose it. And now you can compare these two a little bit better. So this is what we're looking at. Very similar parts, but this one has this groove here. And when we put in the bottom nut, you can actually tilt it forward and back and then tighten it down. So we'll see how that works right now. Let me just get this guy. Oh, I got a little bit of support there I need to remove as well. We'll pop this in here. And don't want to quite tighten it down just yet. Let's get this support out of here. There it goes. Pop goes the weasel. I didn't really expect that to go flying, but that works. So, and you're not going to want to tighten down the front one right away yet either, because what you're going to want to do is actually make that adjustment. So, let's get that in there. And that in there. And we need to loosen that up a little bit. Okay. And this one is a little snug down here by the table. So pretty simple. Let's get a little bit better there. There we go. Right, so there you have it. If I loosen this one here, oh, the bottom one came out on me. Okay, just 1 second, guys. So the flip side of that is if they're not loose enough to turn, they're not going to work. So let's see here. Okay, so if that little T-slot screw doesn't bite down, go ahead and loosen it up a little bit and then try retightening it. Generally, that will take care of the issue. Here, that's just doesn't want to turn. Well, Pug, I think this part could use a little bit of thinning. But I just need to not tighten the screws so much. There we go. Okay, so that one in the top, that one in the bottom. Make sure we have ample room there. All right, 3rd time's the charm. Let's try it again. Also, if you're too close to the front there, this one won't have room to spin and lock into place, so you want to make sure that you're a little bit back from the front of the machine here. And just for a comparison, this was the angle it was at before. So we probably about 20 to 30 degrees we tilted that. So that's basically it for the simple mods. I do have a couple more that we're going to rock out here real quick. And in order to do that, we're going to have to heat up the soldering iron and throw some Glarks into our wheels. And we will change the springs. So let's go ahead. We're going to take the bed off for a moment. So we'll remove these bed clips and set them aside. Just because I don't want it bouncing around while I'm messing with the wheels here. And obviously we're going to have to re-level this thing after it's all said and done, but let's go ahead and get the wheels off. I am way impressed with this machine so far. As I said, I only leveled it the once, which is one of the reasons I'm not going to change the springs. But since we're taking the wheels off, I will show you how to change them real quick. But these ones are a lot more stiff than the original on the E3 or E3 Pro. So these are the original wheels. Got two more in the back here. Bear with me. Three. And let's get number 4 out of the way here. And the bed is obviously still wired up, but at this point, if I disconnected the bed clip, I could simply remove the bed in its entirety. Don't need to do that, though. But this is how you get the bed off if you don't want to take it off the V-slot cover. Let's go over to the soldering station. We'll jump right over here. Yeah, soldering station. I moved a foot to the right. We readjusted the camera. So, I'm going to try to do this at an angle that you can see. I have my soldering iron here, and I have my Glark, and I'm basically just going to use the soldering iron to heat it up and push it into the plastic. Let's see if you can see a little better what's going on here. If I tilt, there we go. And you want to try and go straight in, and you want to make sure that it is as centered as possible. And as you can see, it didn't quite come out the back here, so we're gonna a little further. And, oh, you know what? I'm slacking today, guys. There's still support on here. Where is, there we go, clippers. And let's see if this helps at all. Yeah, there we go, there it is. Peel this off. I gotta de-support the rest of them too. I don't know what I was thinking. Rah, there we go. Okay, so now okay, and that's pretty much it. Once you have those Glarks into the wheels, you can screw them right on. I will need to re-level this again. I haven't adjusted it since I put them on, and it's going to take a little bit of work, but, you know, re-leveling is pretty simple, so should go pretty quickly. And I think that this one is actually a little lopsided in there, so I'm going to have to print another one and adjust that because it annoys me. So But all in all, I am very, very happy with this machine. Like I said, I've only had to level this thing once until I took the wheels off, so it's very, very sturdy. One of the things I'll point out, when I originally got the Ender 3 Pro, the gantry was a little bit loose. And looks like this one's rattled itself a little loose as well. Let's go ahead and tighten this hot end cover down a little bit. There we go. All right, that's better. But the actual carriage itself was loose, as well as needing tightening on the eccentric nut over here. On this machine, everything was flush and ready to go. I haven't really had to dial too much in. It was pretty much just level and print, and I've been printing ever since. All of these mods have come out pretty well. As you can see, I'm printing at a 0.16 millimeter layer height, and you can kind of see the differentiation in layers. You can kind of still see the layers a little bit, but not too bad. And I'm pleased with that. It looks nice. I'm very, very happy with it. This one in this black filament is spectacular. You can't even see the layer lines in this, and it's printed at the same height. Then again, like I said, I wasn't a big fan of that mod. I like the V-slot version better. So that's going to be it. Like I said, there is a bundle down below, the Ender 3 V2 download mod pack. And in that pack, you will find the Dragon hot end, the wheels, the SD card holder, and the side mount spool. Now, the 3v2, as I said, is not available, but if you go ahead and smash that like button, if I can get 100 likes on this video, I will release that version as well. And I wanted to mention that there is also a blank cover in there with the step file included, so you can go ahead and grab that if you'd like to make one with your own customized porthole. And that's basically it, guys. If this video has been helpful to you, like I said, smash that like button. Don't forget to hit subscribe. We're going to do a full review of this machine here next week on 3D Thursday. I just wanted to spend a little bit more time with it before I give you my final evaluation. But so far, my opinion of this thing is pretty high. I've been pretty pleased with everything that's come off it, and it's just a joy to work with. Not to mention the fact that most of the things that they added to this machine are things that people modded themselves on the Ender 3. They seem to take the best versions of each and kind of apply them to the machine, such as the extruder wheel or the drawer down here. The drawer is a nice addition. Like I said, I didn't need to print a tool holder like I did on my 3 Pro because I have the drawer here. But at the same time, the drawer is kind of silly. There's a spot underneath the rail here that is open in the drawer, and you can place stuff in it, but without taking the drawer out completely, you cannot reach it. So I'm thinking I might make an insert tray that slides into here and actually sits out underneath here to catch all my screws and stuff like that as I'm changing stuff out. So if that's something that you'd like to see, leave me a comment down below. And feel free to comment any other mods that you'd like me to try out on this machine. I'm always switching it up and looking to change and see what else we can do. So that's going to be it, guys. Technivorous out. Well, that's it, guys. That's going to wrap up this video. If you've noticed the shirt, the merch is available. Go ahead and check out the Teespring merch link down below. It won't be available on a channel store until I reach 10,000 subscribers, and so far I am just about to hit 5,000. So it'll be a little while, a couple more months before you see this on the actual channel, but they are available now. I have a couple other designs. Feel free to pop over there and check them out, and know that any purchase through the Teespring site definitely helps to promote our site here and increase the channel's ability to make videos in the future. So we appreciate all your support. Don't forget to check out the Teespring link, check out our Patreon link, leave a like on this video, and hit that subscribe button because we have a lot more coming at you in the coming days.
Want to start an online store quickly with products that are ready to sell? Head over to wix.com/dropshipping and launch.
Alright, so Technivorous here, guys. I've been seeing a lot of people having trouble printing PETG on their Ender 3. So I'm going to give you my profile real quick, which is basically my PLA profile with a higher temperature. I'm going to give you a rundown of a few things, and we're going to run a couple quick prints just to show you how easy it is to get it to adhere to the bed. Today I'm going to be running one on PEI and one on the magnetic mat. I did want to show you, now this is some filament.ca filament I got from a Fill-A-Box. And I did really enjoy their PETG, even though I wasn't really a fan of their PLA. It says right here, nozzle temperature 200 to 240. That's a pretty broad range. First thing I want to point out that most people don't know is running on your Ender 3, the nozzle is actually on average 5 to 8 degrees cooler than the thermistor says it is. It's just they have cheap thermistors. It's not a problem, it's just something that we need to adjust for. So Normally when running a PETG, in fact when running most filaments, I tend to start at the high end, which is the opposite of what most people will tell you. But if you look this actual filament up and get their recommendations for printing it on the website, it'll tell you to turn it up as high as you can, and then slowly turn it down until you don't see any burning. By which I mean that turn it down until you don't see any. Alright, so Technivorous here, guys. I've been seeing a lot of people having trouble printing PETG on their Ender 3, so I'm going to give you my profile real quick, which is basically my PLA profile with a higher temperature. I'm going to give you a rundown of a few things, and we're going to run a couple quick prints just to show you how easy it is to get it to adhere to the bed. Today I'm going to be running one on PEI and one on the magnetic mat. I did want to show you, now this is some filaments.ca filament I got from a Filabox, and I did really enjoy their PETG, even though I wasn't really a fan of their PLA. It says right here, nozzle temperature 200 to 240. That's a pretty broad range. First thing I want to point out that most people don't know is running on your Ender 3, the nozzle is actually on average 5 to 8 degrees cooler than the thermistor says it is. It's just they have cheap thermistors. It's not a problem, it's just something that we need to adjust for. So normally when running a PETG, in fact when running most filaments, I tend to start at the high end, which is the opposite of what most people will tell you. But if you look this actual filament up and get their recommendations for printing it on the website, it'll tell you to turn it up as high as you can, and then slowly turn it down until you don't see any burning. By which I mean that turn it down until you don't see any browning or discoloration. Now I have had this printing on what my Ender says is 255. It's probably a little bit closer to 245, 250, but I haven't seen any browning. I did turn it down and I was printing right in that 235 to 240 range. But with the PETG, it is a harder plastic and it does require a higher temperature. So even if you see a lower number there, go ahead and start at the higher temperature and then just kind of dial it back through your print until you find the proper temperature. Another good thing to do is to print a temperature tower, although with PETG you're going to need a specific temperature tower for these temperatures, and you're going to want the tower to start printing at higher than your lowest possible temperature. So you're probably going to want to start at about 210, 215 just to get that first layer to adhere properly, and then you can drop it down and it'll adhere to itself better than it adheres to the bed. So let's jump over to Cura real quick. But let's go in here. I need to check out, everything's looking pretty good. I'm going to change my printing temperature to 245 because I can dial it back from there. I'm going to leave my build plate at 55. That's not super high, but it's not really needed. The PETG shouldn't warp on you like ABS does, so it shouldn't pull away from the bed once you have it adhering. The problem is getting it hot enough coming out of the nozzle to actually stick to the bed. We'll show you that in just a minute. Like I said, I'm going to run on a PEI sheet, and then I'm also going to run one on a magnetic bed. We'll use two different PETG filaments. That way you can see that it's not just the filament that's working really well, it's the process. So the only thing I've changed is my temperature. I do need to go down here. I want to make sure my brim is turned off, put a skirt there. And we're not going to need tree support. So I'm going to go ahead and slice this. I need to make sure that we are hooked up, we are preheating, and actually right now I have a roll of PLA in there. So I'm going to change that out, get this PETG on there real quick. Alright, I've got it all heated up. First things first, I just switched filaments, and I didn't just switch filament brands, I switched filament types. So we're using a completely different kind of plastic. It was PLA, now it's PETG, and in order to ensure that we get our best bed adhesion possible, what we need to do is purge the remaining PLA from the nozzle. So there will still be a little bit of residual plastic in there. You can see some of it melting out. The reason that it is bubbling out like that is because my temperature is way too high for PLA, because we're going to be printing PETG. Now you want to do this also when you switch back to PLA from PETG, and you're going to want to make sure that you do it at a higher temperature so that that PETG is pushed out of there and you don't create a worse clog. So I'm going to go to prepare, move axis, move 1 millimeter extruder, and I'm just going to extrude. And should see it start coming out here in a second. there we go. Still coming out black. That's that PLA. We'll see in a little bit here. It should start to change this nice seafoam green color. There. You can see it starting to change color. I want to make sure that it's all one color, so I'm going to let it quit extruding. I extruded about 30 millimeters, I believe, which is a little excessive, but I want to make sure that that's clear. Now that that's done, I am going to hit my print button, and we'll get started on a print, and I'll show you how well it adheres to the bed. Now, my hot end's heated up. It's at 245 like I said it. The bed's heating up to 55 right now like we said it. It's at about 40 degrees. But I wanted to show you this oozing real quick. This is one of the ways I can tell that I do have the temperature up too high at the moment. So I'm going to crank it down to 240 as the print gets started here. And I'm going to do that now by simply going to Control, Temperature, Nozzle. And you want to keep an eye on this because anytime you change the temperature values before the G-code actually starts running the model, there is a possibility that it will change it to whatever you had set it in Cura when it starts running. So if you have a different initial layer temperature than your starting hot end temperature, it is going to jump on you. Right now you can see it's at 240, 55. We're about 6 degrees away from the bed heating, and it's sitting right where I want it to as far as temperature. I'm going to hold this right here for just a second. It should only take about another 30 seconds to heat up to 55 degrees. And then not only are we going to watch it put down our purge line, but I want to make sure that the temperature doesn't jump back up. Yep, and there it goes. It jumped back up to 245 already. So I'm going to go back in here, Control. Now that I do this the second time, once it's already sent that initial code to the G code to set the temperature, I shouldn't have to do this again unless I have post-processing scripts on that'll change the temperature. Alright, so 239, that should do. You're going to see our first line go down here. This is going to be a purge line. This is essential to make sure that your filament is flowing properly. Oh man, don't mind my messy machine here. Definitely need to do a little dusting, but watch this. Now, it's not going to stick immediately, and this is a perfect demonstration of why you want a purge line. See, it's pushing it out, it's curling up around the nozzle. If you give it just a second, it will grab. There you go, it starts putting it down, and alright, so you can see it's printing. And now here we go down onto the bed. Okay, this is PEI, like I said. I enjoy the PEI. This surface is as smooth as glass, and you can get anything to stick to it. So the only filament I've tried that hasn't stuck to this was a really weird filament from Tallman called T-Glass. Really awesome filament. I will show you how to get it to adhere to the other bed as well. Just real quick, I did want to show you that it is going down without a hitch. I'm not having any problems. And once again, like I said, we'll come back and we'll check on the model when it's complete, and before I remove it from the bed and we switch to the other sheet. Alright, so I'm still going down pretty well. I have dropped my temperature to 231 altogether, and I'm starting to see a little bit of dusting back there, and that is indicative that it's cooling really fast, really rapidly. So at this point, I'm going to go ahead and shut my fan off, and that should give me a lot smoother print. So I'm going to go to, and I just heard it. You can see it slowing down. Pretty dusty. I clean that thing pretty regularly, so don't yell at me. But you can see that now the newer lines that it's putting down don't really have that whitening artifact, and they should come out a lot smoother. Alright, so there you have it, my PETG Stormtrooper bookmark. You can see it's not perfect. I do need to adjust my flow rate, because I'm getting a little bit of over extrusion, but it did come out nice and smooth, adhered to the bed really well. It's dimensionally accurate, and I could easily turn on ironing and adjust my flow rate and smooth this out quite a bit. So I am going to switch over to the magnetic mat and show you that it'll adhere just as well following the same principles, so give me just a second.
Alright, using this old match just like coming home for me. This thing is used and abused. I haven't put it on here in a while because the PEI works so well I haven't needed to change it. So we'll go ahead and start a print on here. You can see it's kind of messy. I'm not even going to bother cleaning it because I really don't use this mat too often. I just want to show you that using the right properties you can get the PETG to adhere to pretty much anything. Alright, there she is, my nasty, dirty old ender mat. This thing is used and abused. It has old filament stuck to it. It is marred, scarred, tore up. It is not the flattest surface. It has fingerprints and dust all over it. And my PETG is still adhering to it. Let that be a testament to the fact that temperature is the major issue here.
Hey folks, Technivorous here. I've had a lot of requests for my Ender 3 V2 profile, and today I'm going to give it to you. And we're also going to go over a couple of the settings just so you know which ones can easily be adjusted without affecting the print quality, and we're going to do that right now, so stay tuned. The Technivorous channel is brought to you by these fine Patreon supporters. If you'd like to check us out on Patreon, pop over to www.patreon.com/Technivorous. That's TECHNIVOROUS. Here, we do our best to stay up to date on the latest and greatest in 3D printing and tech and keep you informed on the latest developments in these sectors. So, if you're interested in getting updates on 3D printing or technology such as programming, robotics, artificial intelligence, and things of that nature, make sure you hit that subscribe button down below, leave a like on this video, and comment about what you'd like to see in the future because we make these videos for you. Alright, so before we jump too far into it, let me give you an example of the kind of quality you're going to get with this print profile. So this is a Black Panther bust that I printed at 0.16 millimeters with this profile, and as you can see, there are virtually no layer lines throughout most of the model. Now, on the back here, you can see a few of them. And it all depends on the angle at which you're viewing it. So they disappear pretty rapidly with just a slight adjustment. This requires very, very minimal finishing. In fact, I wouldn't do any sanding to this model at all on the front here. And I honestly wouldn't be too worried about the back either because it wouldn't really be seen. So this is pretty much ready to prime and paint right off of the printer, which is amazing. Another quick example is one of my hot end covers. As you can see, this is a pretty high quality print, so I think that you guys are going to enjoy using this profile, and I will definitely put a link down below, but let's take a look at it. Alright, we're going to keep this short and sweet. Basically, you can see here I am in my Ender 3 V2 profile. If you're curious about what these are, we are printing some iPad stand holders for the kids' school. Apparently their iPad cases are all broken, so we're going to make sure that this distance learning is a little bit easier. This is a model I knocked up real quick in Fusion 360. Super simple, but effective. It has 2 viewing angles for the screen. You can place it on either side, and it should do the trick quite nicely. But that's not why we're here. We're here to look at the profile. So let's take a look starting at the top. I'm using a 0.16 millimeter layer height. This is easily adjusted between 0.12 and 0.36, right around in there, and still get nice print quality. Of course, the more you increase the layer height, the more visible those layer lines are going to be, but you're also going to get a faster print. We're using 0.2 millimeters for the initial layer height because that helps with bed adhesion, and it is a very simple thing. So the rest of this is all pre-calculated based on these 2 values. Wall thickness at the moment is at 1.2. If you're doing a model like the Black Panther model, I definitely recommend kicking this up to 5, and that will give you a thicker wall thickness here. It should, if it adjusts properly. Or we could do it this way. And that's not necessary, but if it's something that you want to have that nice outer finish and not have to sand too much, definitely increase the walls a little bit. It does work just fine at 1.2 with 3 walls as well. And my infill density is set to 20 off the bat. Now I range between 15 and 25 depending on what I'm printing, but 20 is a great place to start. So this profile is pretty much ready to go right out of the gate. We're printing PLA at 205 degrees Celsius, and we are leaving the bed at 45 degrees. I haven't had any problems with printer adhesion on this printer, so you can absolutely just turn this off if you're using PLA. You don't even really need the bed on. The adhesion on this bed plate is amazing. Print speed is set to 55 in most cases. This is a quality thing. You get a better print when you slow your prints down. You can slow this down quite a bit more if you'd like to get a little bit more quality. Obviously, your print speed is going to be a large determining factor in the overall print time. I have taken this up as high as 80 millimeters per second and still had nice prints. It just gets done a little bit faster, and there's nothing wrong with that. The rest of those are pretty much dialed in based on what they are. If you're looking at the retraction settings for this printer, they're pretty much exactly the same as I run on my Ender 3 Pro. So you're looking at enabled retraction, 6.5 millimeters at 25 millimeters per second, and that is the retraction speed as well as the prime speed. So that's how fast it pulls it out and how fast it feeds it back in. The rest of these settings are going to be basically based on what you're printing. So enable print cooling is turned off on the bat. So this is basically a good to go PLA profile. There would be a couple adjustments you want to make to switch to PETG or ABS, but for right now this is a great place to start, and I have other videos that'll show you what adjustments you need to make there. I have support turned on. As you can see in this model, it is not generating any because there are no overhangs. Oh, I need to slice first so you can see. So we'll come back and look at that in a second. You can easily turn support off if you prefer not to print with it. I leave it on most cases because if there's no overhang, it doesn't print it. If there is an overhang, it calculates and prints it. We're using a skirt. This can easily be changed to a brim or a raft without affecting the overall quality of the print as well. The rest is basically up to you. So we're going to leave it at that. And as you can see, like I said, no overhangs, no supports. Even though it's turned on, it's not printing them because it doesn't need them. So this is a pretty straightforward, short and simple, and to the point. If you'd like to get a hold of this profile, I will have a link to it in the description down below. Go ahead and jump over to my GitHub and hit the download button, and you can import it right into Cura. On a side note, don't forget to hit that subscribe button. Leave a like on this video if this profile has been helpful to you, and please share this profile with everybody you can, because I've had a lot of requests for it, and I think there might be a couple people out there struggling with getting a perfect print profile dialed in on the Ender 3 V2, and this one, I can tell you from experience, is going to be spot on. Well, that's it, guys. That's going to wrap up this video. If you've noticed the shirt, the merch is available. Go ahead and check out the Teespring merch link down below. It won't be available on a channel store until I reach 10,000 subscribers, and so far I am just about to hit 5,000. So it'll be a little while, a couple more months before you see this on the actual channel, but they are available now. I have a couple other designs. Feel free to pop over there and check them out, and know that any purchase through the Teespring site definitely helps to promote our site here and increase the channel's ability to make videos in the future. So we appreciate all your support. Don't forget to check out the Teespring link, check out our Patreon link, leave a like on this video, and hit that subscribe button because we have a lot more coming at you in the coming days.
So, what you see here is Creality Slicer. This is Creality Slicer 1.2.3, the latest version of Creality's in-house slicer, which runs on the Cura engine. It's basically a cloned, reskinned, and slightly updated version of Cura 3.4. Yeah, 3.4. Remember, back when Cura was good? The interface feels almost retro, and all tabby over here on the left, but it's simple and it's effective. It's not just good, it feels like coming home. All the settings you want are easy to find, with extra settings only a click away, such as quality settings that include layer height, shell thickness, and retraction settings, which can be expanded upon for further setting adjustment. And that's just for quality. It has all of the other obvious settings such as temperature and speed, and there are some advanced settings here as well, such as retraction, retraction speed, and distance. A couple other settings in the advanced for quality, but if all of this beautiful simplicity is too much for you, all you have to do is switch it over to Quick Print. Now, Quick Print is perfect for places like schools or libraries where you want to get a system set up to allow other people to attempt to print models simply in the easiest way by importing them, selecting a material and a profile, and hitting print. So you will have to ensure that you have good quality work, and the models I were printing on the stock Ender 3 settings were pretty much amazing. I immediately realized why the test dot came out so nice. It had to be sliced with the Creality slicer. But why then was generic Cura what was placed on my micro SD when I got the machine, right next to the dog file? Who knows? But if you have a Creality machine, I highly suggest ditching Cura and its bugs, and at this point, it's just overextended. They keep adding features before they're ready and not fixing the problems from the last time. I don't know, maybe they need some sort of skunkworks over at Cura to see this and go rogue, secretly going back to a version that worked and building up on that. It would be a nice surprise to get a solid version. And that's what Creality Slicer feels like. A solid, stable version of Cura without all the fluff. Once again though, I find myself wondering why they don't ship this with every machine. There's so many fans of the Ender 3 alone that support vanilla Cura. If Creality put a little polish on this slicer and pushed it with every printer, Cura would be working for them, and PrusaSlicer would be in for a real fight. Instead, they seem content to secret this away and silently make it available for download, while any Creality forum you join pushes Cura, because at this point, it's what people know. I feel like Creality is really missing the boat on this one, and so are you if you're not at least checking this slicer out. Now, don't immediately go and delete Cura. The truth is, this slicer's not perfect, but none of them are. I'm just saying I've had really great results with the profiles built into this version of Cura, quote unquote, and it looks nice, it works well, it's simple without being overly complicated, and I mean, it's basically made for your machine if you own a Creality printer. So if you're not checking it out, it's kind of silly. There are a couple other cool things to check out in here, such as the other kinds of modes. There's a transparent mode, which does exactly what it says. This might be useful for making intersecting objects, things of that nature. There's also an X-ray mode, just kind of turns it blue and does the same thing, and I'm not quite sure what the difference is as to why it has these two modes. There's also an overhang mode, which will show you your red spots that you get pretty much all the time in Cura to see where you're going to need support. We can go back to normal mode, and then the layer mode I was showing you while I was yapping just a minute ago. This is basically after it's sliced. Now it is set to slice automatically, so right off the bat, anytime you change a setting, it's going to reslice your model, and that to me is slightly annoying, kind of a drawback. Cura, there's a way to go in and turn that setting off so it doesn't do that constantly and only slices when you tell it to. But I haven't really dug deep enough into here to find that for this yet. And I don't believe, actually, that they made the ability to turn that off until a later version of Cura anyway. As I said, this is version 1.2.3, meaning they have iterated on it a couple of times since they have taken the engine from Cura, so they've done a few tweaks and changes and things like that. Obviously, you can see visually the aesthetic is a lot like the older versions of Cura. They have customized a few of the icons. This just brings you to the Creality website, but they do have the Creality plate in here, and all of the Creality printers that I've seen so far were pre-programmed in here with profiles. So if you have a Creality printer, you should be able to just jump in here, hit the button that says English, obviously, because you don't want directions in Chinese, and then select your printer, and it was pretty much as easy as that. The other thing I noticed, and you're not going to notice right now because I accidentally changed this earlier, but this setting for the stock Ender 3 profile was set at 0.15. Now, if you want to get into a debate about magic numbers, 0.15 is not one of them for this machine. However, I have gotten really nice prints at 0.15, and before I knew about magic numbers, that was the one layer height that I found that consistently gave me good prints. If you don't know what magic numbers are, I have a video about it somewhere around here on the channel, but I highly recommend checking out Chuck Hellebeck's on Filament Friday on magic numbers, because they have a lot to do with the print quality. If you look at my video on magic numbers, you'll see I printed two different Lightning McQueens, one at 0.15 and one at 0.16. They both came out looking nice, but there were details on the 0.16 millimeter that were just missing on the 0.15 millimeter. Dimensional accuracy was there, everything was pretty close, but there were small subtle details such as raised ridges on Lightning's hood and eyebrows and things like that. Things I didn't notice were missing until I had the 0.16 model to compare it to. So definitely look into magic numbers, but you won't have any problems printing at that 0.15 millimeter height. You just may not get the exact type of resolution quality you're looking for as you would if printing at a magic number. So other than those two little caveats, I have had a lot of fun playing around with this. I'm going to print a bunch more models. We'll come back and revisit this later and check out some of the things that I printed, but for now, I just kind of wanted to make everybody aware that this was out there, and I'll put the link in the description down below. Go check it out, give them a shot. I mean, it's a lot. I would say it's dumbed down from Cura now, but it just seems like it's decluttered and still has all the functional parts that you want. So it's definitely worth your time, and that's going to be it for this video. Thanks, guys. As always, this channel is brought to you by these fine Patreon supporters. If you'd like to support the channel on Patreon, head over to www.patreon.com/Technivorous. Alright guys, that's going to be the end of this video. As always,
welcome
thank
to
you.
this episode
I'll
of
put a
Cura Questions. I get a lot of questions lately about the new monotonic mode in Cura 4.11 and ironing and whether they work together. So let's check it out right now. Hey guys, Technivorous here, and welcome to this episode of Cura Questions. I get a lot of questions lately about the new monotonic mode in Cura 4.11 and ironing and whether they work together. So let's check it out right now. So today we're going to jump right into it, and I have two questions from the same user. They're both from a person named Green Apple Pie. Apple. And the questions are, will all my custom profiles still be there if I update? And will all the current add-ons from the marketplace still work if I update? Now this is a great question, and it has a couple of answers, so let me explain why. We're going to jump over to Cura here, and this person is talking about updating to the new Cura 4.11. Now I will say, when you update, you will be given the option to keep your old version, and if you keep your old version, it will keep all of the stuff in that old version in its own separate folder, and your profiles and your add-ons will stay with that old version. That said, if you choose not to keep that old version, Cura will do its best to import all of your profiles and the add-ons into the new version by moving those folders, but that doesn't necessarily always work the best. So in a lot of cases, the best thing that you can do is simply take and select keep old version, and then in your new version, go ahead and re-download those add-ons, or you can even actually copy and paste the folder.
in most cases to the new Cura folder. I do the copy and paste thing with my themes. You can change the theme in Cura. Let's go configure Cura. There's a special folder in your Cura folder that will allow I think maybe we should go and do that now just to kind of show you how that works. So let me find my Cura folder and I will be right back. Hey folks, Technivorous here, and today we're going to be taking a look at slicers. Specifically, I have 10 alternative free slicers for you to check out, and we're going to jump over and take a look at that right now. But if you find yourself struggling with the slicer you're using now, or you don't want to pay for software, this is a great place to start because I'm going to show you some things you might not have seen before. So stick around, I've got a lot to show you on the Technivorous channel. First of all, we're going to start with the obvious. A list of free slicers can be shown easily just by Googling them and finding a list of free slicers. That's all you got to type in. In this case, I was returned 9 slicers and 6 of these are free. Now, I do have some other links open up at the top that I'm going to go through here in a minute. There are 10 slicers, although I will tell you, as we look at this, as you see here, Slicer and PrusaSlicer, these are technically branches of the same software, and that's going to be the same in a couple cases for a couple of these slicers, such as Cura and Creality Slicer, which I will also give you the link to. Creality Slicer is a skinned version of Cura with some individually, purposefully left out settings and not too much added in, so it's a little bit scaled back. If you want full functionality, you have to get the actual Cura, and they update that a lot more regularly. But I digress. Let's go through this list real quick here. Everybody knows about Cura, so I'm not really going to touch on that one. It's pretty popular. It's the one that people recommend the most, honestly, unless you have a Prusa machine, in which case you're going to be recommended PrusaSlicer the most. However, if you don't like either of those slicers and you'd like to check out some alternatives, well, that's why we're here. So the first ones I want to point out on this list are actually not even showing up on this page, okay? So Cura and PrusaSlicer are the best and easiest to use on this free list, but there are other free slicers. We're going to come back to this list in a second. I'd like to visit IdeaMaker real quick. IdeaMaker is Ray's 3D slicer, and you can set it up to work with any printer. It works really well. It has a couple of really cool things. There's texturing on models, all sorts of really, really cool stuff in here, as well as primitives and other items that you can use to add and subtract and combine and make models. So this one is a really, really clean, very, very nice slicer. I definitely recommend checking that out if you're in the market for something different. And the address for that is at the top here, raise3d.com/IdeaMaker. You can also just Google IdeaMaker. I will have a link for that in the section down below in the description. And we're going to check out another 3D printer making company. This is Matter Hackers. This is Matter Control. So Matter Hackers makes and distributes 3D printing supplies, and this is for their printers. But it does work with other printers as well. And then the next one is going to be Creality Slicer. Now this is the one I get asked about the most on the channel. People want to know where to get this. Usually if you buy a Creality machine, this is the software that will come on your disc, and it is exactly like Cura. It is a cloned version of Cura with a Creality skin. So they're on build 4.8.2, and what they do is, like I said, they intentionally leave out some features that haven't been tested as long in the software instead of putting them out. So less bugs, but also less features. They do catch up in batches to Cura by doing updates relatively quickly. I mean, it's pretty normal. You can see they're on 4.8. Cura's on 4.13. So that means the last time these guys updated, Cura was on 4.8, because they don't update through iterations. They just, whatever iteration they're cloning, they take stuff out. And anyway, great slicer if you have a Creality machine, and you can also add other machines to it like Cura. It's just prettier. It looks cool for having a skin. The next one is actually probably one of the most interesting. Now this one is downloadable, but I've loaded it here in the browser, and the weird thing about this is the interesting stuff that you can do. So you can't see it here because this is the online version. It'll allow me to load an STL and slice and set all these settings. But with this one, you can actually type in primitive models using your own code and build models basically just all out of code, which is really, really cool. I do have some videos on IceSL around my channel here, so if you're interested in seeing more on this particular slicer, definitely search my channel for those. You'll find some cool stuff. And on that note, we are going to be going through pretty much all of these slicers in depth in their own video. I have done all of them before, but that was a couple versions ago for most of them. So let's go back to our main list, and we're going to skip talking about Simplify 3D because it's paid, and that's not what this is about, and SelfCAD as well. We are going to touch on KissSlicer real quick. It is paid with a free option. The free option is not as robust as the paid option, but KissSlicer is intense. KISS here stands for Keep It Simple Stupid, which the slicer really is not. It can be a little complicated at times, but for dialing in little minute details that you can't get anywhere else, KissSlicer is simply the best slicer for tuning your printer and getting exactly perfectly defined prints. Now, that's based on me using Marlin, not using Clipper or any of those other softwares. It's just the most common printer, the most common software. If you use this on an Ender 3 and you dial the settings in right, you're going to get beauty every time. Okay? And that's even with the free option. I personally have not tried the paid option, but I did get some really nice prints out of the free version. So the next one is Tinkering Suite. That one's free. I have not tried this one. I think I'm going to grab it and check it out. Although, if I recall, maybe I did touch on it once in the past, and it was really, really simple. So that one is available as well, and you can get it at their download page. So, by the way, I will be pasting this for the main bulk of these links, and then these other ones I'll have individually. I do recommend checking these out. They are really good products. Then you have PrusaSlicer. PrusaSlicer can be found on Prusa's page. PrusaSlicer is an amazing slicer, especially if you have a Prusa machine. And the cool thing about PrusaSlicer is if you're into their machines and you have an FDM and an MSLA machine, it can slice for both of them in the same software, which is really, really cool. We can talk about Octoprint for just a second. It is completely free. If you're not a techie person, you're not into Raspberry Pis, it can be a little bit intricate to set up. It's not that difficult, and a lot of people do it. It is very, very common, but it is a little bit more in-depth to get Octoprint running on your machine. And then you have Repeater. Now, Repeater Host is technically not a slicer. If you're curious about testing multiple slicers instead of just downloading all of them, what I would do is download Repeater, because there are options to use the slicing engine from different slicers. So basically, it is a host engine that will allow you to set your settings, and then you can pick, say, PrusaSlicer's engine, or you can pick Cura's engine, and you can slice it with either of those. So the settings aren't quite as intuitive as those two programs, but that's because this program is built to work with other engines for slicing other than just one that's built into it. So really, really cool software. I would check that out as well. And like I said, you'd be hard pressed to find a slicer that I haven't tried. I have tried Simplified 3D, even the paid version. I was not really impressed with it. And I can tell you at the end of this video that any one of these free slicers are just as good, if not better, than the Simplified 3D slicer. And I know that hurts them to hear me say, but it's a fact. It's just a waste of money when there's so many other good free products that you can use. I highly recommend sharing this out with everybody. Hit that like button so YouTube will share it as well. And I'd appreciate it if you hit the subscribe button. That way you get notified when I post videos on each of these slicers, and you won't have to download them yourself. You can just kind of check it out and see which one looks the best for you. That's going to be it for this video, guys. I appreciate you as always. It's been a pretty good year so far. I've been laying a little bit low, but you're going to see me getting back into doing videos a lot more often now that I have a little more free time on my hands. So thanks, guys. That's going to be it for this one. Technivorous out.
Stick around, guys. I got another YouTube recommended video for you right here. And if you haven't already, subscribe. Make sure that
It's going to be very much opinion-based and subjective, meaning it's going to depend on the situation and the person in that situation. What they offer forward is the best. You'll notice here, I do have a lot of walls in this slice, and there's a reason for that. I will talk about that in a few minutes. For right now, you can notice I have the triangle infill on, and it's not that I'm particularly attached to the triangles. It's just what I happen to switch to when I slice this. The thing we're going to talk about is benefits to using different infills. Okay, different infills don't really have different purposes structurally. Now, there's some debate as to which infill is the strongest if you're trying to make a part that is the strongest part you can make. And the answer to that is always to print it at about 98% and make it almost completely solid. Now, you don't want to do 100%. Most cases that will over extrude. But if you're going for a solid part, just print it solid. It doesn't matter what infill you pick. It's not going to be a very big strength differences. And there are videos on this that will explain to you exactly why that is. But today, I do want to touch on a few other things. There are reasons, obviously, to print your objects with infill instead of using all the filament it would take to fill the interior cavity of the whole object. Okay? So what are the benefits to using different ones if you have to use them? So obviously, we're going to be using infill. Why would I want to pick one in particular over the other? Well, that's basically going to come down to the pathing and the design of that particular infill. So some of these are pretty simple, like the grid, and some of them are pretty complicated, like the Cross 3D and Gyroid. Now, they do look, or not Gyroid. Gyroid's pretty simple. It's just a wavy line in both directions. Concentric can get difficult. Quarter cubic, and both of the crosses actually are time intensive for doing the lines. And the longer the path is to draw that infill pattern in there, the longer your print is going to take. Okay, so that brings me to my point on how I'm judging or determining the best infill pattern to use, and that is for my purposes. Again, I said this video is subjective. My purposes when it comes to the infill in particular, I don't want to see the infill when the model is complete. I do want it to be there in some cases, and when I do, it doesn't matter to me what the pattern is. Now, in some cases when you print, if you don't have enough walls, your infill pattern is going to show through the print object, and that can be less than ideal. So in that case, you're going to want to increase your walls by one layer at a time until that artifacting kind of disappears. So then at that point, it really shouldn't matter what your pattern is. Whatever's getting you your print the fastest and having a quality exterior and using the right amount of infill and everything. So the purpose of all of these extra walls here, now obviously in most cases you're not going to need to go that thick. With the infill, a lot of them, 4-5 layers at the most, will usually cover them up. Sometimes you can get away with 3. Here I have several turned on, and the reason for that is there are models that in most cases can be sliced without any infill whatsoever. Okay, that means you're just printing the shell of the model. It doesn't mean you have to fill it up 100% completely. Check out Joel Telling's video on this. He printed a big Pikachu without any interior filling. I think it was a Pikachu. And I know there's several other videos on it as well. In fact, I have one here on my channel I don't really feel like digging it out. It wasn't the best video, but the information is there, and you can print without the interior in most cases if you increase the walls to between 8 and 10 or more. And what that does is it allows the interior to be built up around the interior of the shell, and it'll print the last wall of the outer wall last, so it has the most structure to adhere to, and you get some really nice models this way. Now you might run into a problem with super flat top surfaces doing this, but for objects where you have models that are like even miniatures and have figurine or have heads at the top, or rounded objects like that, it works really, really well. Diablo here would actually be a decent candidate to try it out with. Let's get out of the preview and see if it's less laggy. There we go. So if I were to print this without infill, the only real problems I would run into might be a small spot right in here. But for the most part, okay, and you can kind of see how it works. Now imagine without the infill there, that you would just be getting these walls. And that will leave you with a completely hollow model, but in most cases saving that plastic works really well, and you don't really necessarily need the infill. It's kind of just a waste of space. It's used for structural support for the tops of overhang models that are super flat on top. Obviously you can't print on nothing. One of the other interesting things that can save you time and filament if you're interested in trying out the no support technique or the no infill technique is variable infill. You can set it to print different amounts at different heights, so it'll basically build a cone upwards like this. So it's using very little at the bottom and then getting wider and wider on top of that, and then that'll support your spaces, and that uses a lot less filament than full infill. Now you are going to use full infill on a lot of your models, and in that case I encourage you to play around with, in particular, the grid and the gyroid, because the gyroid is pretty static no matter what. It's two wavy lines that cross each other, but it's very straightforward with the back and forth, and the pathing is quick. When you get to like the cross and cross 3D, your time is going to take a lot more time because it's making an intricate pattern that you're never going to see. As far as structural integrity, again, I touched on those videos that are out there that will go over this, and you can definitely check for some of those on YouTube, but for the most part, you're not going to notice any difference in part strength, simply because the orientation of the part is going to be more important to its strength than the infill, because of the way that 3D printing is anisotropic. It's simply one layer on top of another layer on top of another layer. So if there's a shearing force that goes against those layers, it'll rip them apart regardless of how they're attached in the middle. Now, certain infill patterns may have more connection points inside and reduce the damage, but none of them are really going to make the actual item stronger than the actual layer adhesion between two layers. So I hope this was helpful to you. I'm sorry I didn't give you a definitive answer for which one is the best. I do try them all. I like making time lapses of some of the more longer and intricate ones, but for the most part, go with grid or lines or even triangles or the gyroid down there just to save yourself some time. Infill is not necessarily needed at this point, and as printers get better and faster, it's going to be less of a thing. So that's going to be it for this, guys. If you have any Cura questions, leave them in the comments down below. I am dragging my tongue through this. Like, I feel like I can't talk. I've had a couple days off. We had a unscheduled vacation from YouTube, if any of y'all heard about that. But yeah, leave a like, hit subscribe. We'll see you in the next video. If you got questions, let me know.
Stick around, guys. I got another YouTube recommended video for you right here. And if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out.
Hey folks, and welcome. Today I'm going to show you where to get my all-new Creality Ender 3 V2 profile for Cura that works with Cura 4.11, so stay tuned. Hey folks, Technivorous here. You know, every once in a while, Cura will release a version that pretty much breaks all of your prior profiles. So it's that day today. We are re-uploading my Ender 3 V2 profile. I'll tell you where you can get it at the end of this video. But for right now, let's go over some of these settings real quick, because we're making some quick updates. And I want to make sure that everything's correct. So you can see we have the layer height set to 0.16, initial layer height 0.24. That is going to be a medium quality model. If you want a finer layer height, go ahead and add it in here. The wall thickness is 1.6. Now generally I set this to 2.0, but for my profile I have set it to 1.6 to reduce the wall layers by 1. Now the reason that I set it to that extra wall layer is to ensure that no infill shows through, and also to be able to print without any infill at all if I want to, by just turning the infill on and off. Now 5 is generally the minimum number of walls you're going to want if you're printing with no infill, but we'll get into that in another video. For now, let's continue on. Top and bottom thickness is going to be 5 layers, so it's 0.68 millimeters. And the reason that 5 layers here is different than 5 layers here is because the initial layer height and the layer height. So the layer height is 0.16. It's slightly more than a quarter of what the line width is. So they're not the same values, so keep that in mind. Infill density we are going to set to a solid 18%. That's not too bad. Generally you want to be between 15 and 20. And our printing temperature we're going to leave at 220. We will reduce it based on what we see on our plastic filaments in most cases. Now that that's done, I can see there's obviously an error down here. It's nice when you see this orange popping up, because that is generally the system telling you, hey, are you sure this is right? You might want to double check it. So obviously I'm not going to be trying to print at 370 millimeters per second, and in fact with these machines, if you tried to print that fast, it wouldn't go that fast. There are firmware limits that you cannot supersede by changing the G code in here. You actually have to change the firmware. A good starting point for the Ender 3 V2 though, it does have a pretty decent clip to it, is 80 millimeters per second. Now that's going to get you very good detail and a very nice model without taking forever. If you need a slightly higher quality model, reduce this number to between 50 and 60, and if you want the model to go a little faster, feel free to crank it up to 100 and 120, somewhere in there. Now you can put it all the way up to 150, which is the max, but the higher it goes, the more likely you are going to cause vibrations in your machine that will over time loosen parts of the machine and cause vibration, ringing, and things like that that you don't want in your print. So the Ender 3 V2 is fairly capable of running at its maximum speed efficiently, but if you're going to be running it at its maximum speed a lot, make sure that you are checking all of the nuts and making sure everything is tight and square after running a couple of prints, because you don't want it to just wobble itself apart. I've seen it happen. It is not pretty. So let's roll on to the next section. That is going to be travel. We do have our retraction enabled. I see another error here in the retraction distance. I actually want this to be 5.5. Now with the Ender 3 V2 it was 6.5. In some cases I've seen it go down to 4.5. That 1.5 you just saw was what I was using for a direct drive machine, which this machine is not. So this retraction distance is specifically tailored to my Ender 3 V2 machine and works really, really well. We are going to go ahead and leave the retraction speed where it is, and we don't need to mess with any of the retraction settings further than that. So this part here is something that I like to leave on, but I want to warn you, this is going to add to your print time. Now avoid printed parts while traveling and avoid supports while traveling will keep the nozzle from running into a part that's already made while it's pathing to the next point on the model to print. However, since it is not going from point A to point B, in most cases it's going around an object, it does add to your print time on each layer. So if you're taking too long to print, feel free to try turning one of these off. Sometimes you can get away with it. The avoid supports when traveling, usually you can get away with that if you're on a tree support system, but if you're doing just vertical line support, you definitely want to leave that on so you aren't knocking them over. And this is a PLA profile, so print cooling is turned on and it is maxed out. I do have generate support turned on. The support pattern is set to zigzag, and I'm going to go ahead and change that because my normal tree support, or my normal support structure, is tree support. And I'm also going to change the overhang angle. Now I know from doing my overhang test that I can go up to about a 65-degree angle before seeing any droopage on this machine. So I'm going to stay below that parameter in order to keep my model nice and clean, and I'm going to go with a 60-degree angle here. Support pattern is not really important, and I'm going to go ahead and leave it with lines. Support density is kind of important. That determines how much support is put underneath the object, how thick it is. Okay. And then there is support infill. Okay, and the support infill pattern is this pattern right here. And in most cases, yeah, I mean, we don't even need the support infill. You do want the support interface turned on, and my build plate adhesion is set to a skirt. Now, in previous versions, it had been set to a raft. So if you would like the raft back, this is where you change that. You simply click on skirt and select it from the drop-down menu. I've since switched to the skirt because I've upgraded to a slightly better build plate, and I have really, really good adhesion on the Ender 3 V2 build plate versus the Ender 3 Pro, which was that magnetic mat. So I don't really need the raft as much. If I'm printing a large flat part or a part with angled corners that I don't want to lift away, then I'll print it with a raft. But generally only after I already mess up a print and realize, hey, I should probably put a raft on that one. But for the most part, you save a lot of plastic not using it. I love rafts. People argue with me all day when I use them that they're stupid and not to bother, but they do have a purpose. So that is not what I'm trying to say. The rest of this stuff is special modes, dual extrusion, and experimental, not really applying to the Ender 3 V2. So there you have it. There is our profile. We are going to upload this. This will be up on my GitHub, and it is going to be the 2021 version, so make sure you grab the right one. There are legacy versions if you're using an older version of Cura, but if you are using Cura 4.11, you need this version. This version will also work with older versions. It's just the older version doesn't tend to work with this one, and I've seen that with a lot of people's profiles. I see Chep just had to update his profiles as well, and I've had some comments and requests for me to update them, and that's one of the reasons that I filed this under the Cura questions label. Just go in here and click advanced. It'll show you all of the settings that I have open, and you'll be able to just follow the video really easily. If you'd like to take it up a step from there and fine-tune the profile even more once you have it where you want it, then you can go ahead and click expert, and that'll give you even more settings, or even all, which will open all of the settings, and then you can kind of dial it exactly where you want it. But this should be a great starting point for you. Let me know how this works out for you, this profile, and definitely leave me a comment down below. If you have any Cura questions, there is a Cura questions playlist. I'll put a card up over there. Yeah, over there. I'm telling you, you can click on to go to the playlist. There's over 30 videos in that playlist. I answer Cura questions all the time. I love doing it. So if you have a question, like I said, leave it in the comments. Don't forget to hit that like button and subscribe to the channel, because we have a lot more coming at you in the coming days. Pretty soon you'll see the full-on review of my Creality Halot 1. I am loving this machine, by the way, and we have a lot more fun stuff coming down the pipe. So that's going to be it for this one, guys. We will see you in the next one. Technivorous out. Stick around, guys. I got another YouTube recommended video for you right here, and if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out. Hey guys, Technivorous here, and welcome to this episode of Cura Questions. I get a lot of questions lately about the new monotonic mode in Cura 4.11 and ironing and whether they work together, so let's check it out right now. Welcome, folks. We are back in it today. We are looking at the all-new monotonic ordering mode in Cura. Now, I've had a couple of questions about this. Is it really smoother, and can you use it with ironing? So today we're going to take an in-depth look, and I have here 4 models. You can see they are 4 exact copies of the same model, and I've put them into per model settings. So what I'm going to do here is go in, and the first model is going to be no monotonic and no ironing. Second model is going to be ironing without monotonic. Then the third model is going to be monotonic ordering with no ironing. And then this one will be monotonic ordering and ironing. So if we take a look, you can see that if I back through this here, it is doing a pretty good job. This one's only going to be 1 layer on the top for this square because it is the non-monotonic, non-ironed layer. You can see it going backwards, but if I go all the way back down here to the first one, you can see it does a pretty good job with the monotonic. It'll do the walls and then do its best to keep it in a straight line there. And the same over here, except this one is going to add in a second ironing layer, which is also monotonically designed. So let's see if we get results that are smoother with this one than this one. And I mean, it should kind of go worst, best, and then these two should both fall somewhere in the middle. But we'll see what happens. So let's save the file and jump over to the printer.
And here we have them, our finished models. And at first glance, they may not look much different, but when I zoom in, you can clearly see the two on the left, which did not have ironing turned on, compared to the two on the right are not nearly as smooth. So the ironing definitely does help. And let's see, I think I see a little bit of blurring here and here where the seams were connected. Picture I'm going to show should illustrate it pretty well. Ironing definitely does work with monotonic mode, and this is the best top surface I've seen from Cura yet. This is monotonic and ironing turned on. The regular one with ironing, about what we expected. It came out really nice, but not quite as nice as this. You can see, if I get the light just right, you can see a little bit more scarring in here from dragging across the ironed top. And that is because it doesn't fill it in a singular order across there like this one. So pretty flawless part. I'll be using ironing with monotonic mode a lot more often. And if you want super smooth prints, I definitely recommend using those two options together. That's going to be it for this video, guys. I will see you in the next one. Don't forget to hit that subscribe button and leave your Cura questions down below. Stick around, guys. I got another YouTube recommended video for you right here. And if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out.
Hey guys, Technivorous here, and welcome to this episode of Cura Questions. I get a lot of questions lately about the new monotonic mode in Cura 4.11 and ironing and whether they work together. So let's check it out right now. Welcome, folks. We are back in it today. We are looking at the all-new monotonic ordering mode in Cura. Now, I've had a couple of questions about this. Is it really smoother, and can you use it with ironing? So today, we're going to take an in-depth look, and I have here 4 models. You can see they are 4 exact copies of the same model, and I've put them into per model settings. So what I'm going to do here is go in, and the first model is going to be no monotonic and no ironing. Second model is going to be ironing without monotonic. Then the third model is going to be monotonic ordering with no ironing. And then this one will be monotonic ordering and ironing. So if we take a look, you can see that if I back through this here, it is doing a pretty good job. This one's only going to be 1 layer on the top for this square because it is the non-monotonic, non-ironed layer. You can see it going backwards. So if I go all the way back down here to the first one, you can see it does a pretty good job with the monotonic. It'll do the walls and then do its best to keep it in a straight line there. And the same over here, except this one is going to add in a second ironing layer, which is also monotonically designed. So let's see if we get results that are smoother with this one than this one. And I mean, it should kind of go worst, best, and then these two should both fall somewhere in the middle. But we'll see what happens. So let's save the file and jump over to the printer.
And here we have them, our finished models. And at first glance, they may not look much different, but when I zoom in, you can clearly see the two on the left, which did not have ironing turned on, compared to the two on the right are not nearly as smooth. So the ironing definitely does help. And let's see, I think I see a little bit of blurring here and here where the seams were connected. And monotonic mode doesn't seem to have that. So if we can get them both in the picture here, it does look like this one is a little bit cleaner. So monotonic mode is a win. Also, and I'll put some pictures up here that do a little bit more justice, but this surface is super smooth. I think you can see that in the picture I'm going to show should illustrate it pretty well. Ironing definitely does work with monotonic mode, and this is the best top surface I've seen from Cura yet. This is monotonic and ironing turned on. The regular one with ironing, about what we expected. It came out really nice, but not quite as nice as this. You can see, if I get the light just right, you can see a little bit more scarring in here from dragging across the ironed top. and that is because it doesn't fill it in a singular order across there like this one. So pretty flawless part. I'll be using ironing with monotonic mode a lot more often, and if you want super smooth prints, I definitely recommend using those two options together. That's going to be it for this video, guys. I will see you in the next one. Don't forget to hit that subscribe button and leave your Cura questions down below. Stick around, guys. I got another YouTube recommended video for you right here, and if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out.
So I have restarted another print, and I immediately turned it down to 0.75, and that gives us 60 millimeters per second. So this is a doable speed. However, made this just a button. All you have to do is click, and it works. We're going to be checking that out in just a second. The other thing I wanted to look at was this blurb right here. So this is a thank you to Cura for staying open source. They've ported the popular fuzzy skin feature from Cura into PrusaSlicer. Now, the thing I want to point out about this is I really appreciate these guys doing this, and also thanking Cura. Cura has been known to take a couple of things from them, like their range algorithm and things like that. So it's nice to see them competing, but also willing to work with each other in order to make them better. So that is really cool. We'll take a look at that as well. Some other stuff in here. The last thing I wanted to show you in here, sorry about all the scrolling, is this one right here. This is sign mode. So from now on, it detects when it thinks you're printing a sign, and it'll ask you if you want to put layer separation in there. So we're going to take a look at that as well. Let's jump over to PrusaSlicer and see what's good. Alright, so first and foremost, the first thing I wanted to look at here, let's grab us an STL. I have several. We're going to grab a sign that I just made to test out this sign system. Now here I have a flat file, and then I have two different height variations. So the Technivorous text and the border are at 2 millimeters, and the 3D printing text is at 1 millimeter. So in theory, it should detect that. It should be able to tell that this is a sign, and it should ask us if we want to slice it separately. So let's click the slice button, and here it is. Here's our note. So let's apply auto color change to print, and click yes. Okay, so now we're down at the bottom. If we scroll all the way up, we see that we have three different colors here. So it's going to give us two M600 commands. You can see here, and that is going to manually stop the printer so we can change the filament and change the colors to finish our signs. So that is a really handy thing to have in there if you do a lot of sign or multicolor printing, and I really like that quick addition. So let's see what else we got. We're going to go back to the platter here and remove this guy, and I'm going to bring in another random file because we're just going to cut a hole in it, and I'm going to show you how easy it is to use this new feature. So I have a bottom of a computer mouse here, and let's go ahead, let's get a good view of it. And we will grab it, and we will click right here, and I think we'll just say add negative volume. Now you can either choose a box, a cylinder, a sphere, or a slab. In our case, we're going to load, and we're going to grab something a bit funky. So let's see, I have I want something that's not regular. Let's do, this should cut a bunch of pieces out of it. So we'll grab this model, we'll drag it over here. If you remember, it's printing this as a negative volume, so all we need to do is make sure that it's going through the model. At the bottom there. Slice this guy, and it should show several holes in the model and not show that second piece we brought in at all. And in fact, there you are. It's leaving outlines of all the models. Excuse me, sorry about that. Leaving outlines of all the models that we cut out. So you can do that with simple models, complex models. It's actually really fast and a little bit simpler than Cura's version of doing things. So I'm very happy with that as well. Now, one of the other things we wanted to look at in here was fuzzy mode. So let's go ahead and add a modifier here. So let's go to add part. We're just going to load a sphere like they do in the preview of this on the page, and we're going to drag that over here. add settings, fuzzy skin, okay, fuzzy skin. We actually need to make this a modifier. Okay, so I think I did that right. We'll find out. So when I slice this, it should, yeah, there you go. So it's putting fuzzy skin on the area that's in contact. So right here, right where that sphere was touching. Pretty cool little trick for just fuzzitizing a part of it. It does also do the inside, something to be aware of. And yeah, that is pretty cool. Now there are a couple other additions in this version of PrusaSlicer that are worth a look. So I definitely recommend downloading the alpha and checking it out. But as with Cura, you always want to keep the old version if you're working with alpha or beta software, and make sure that you're not overextending yourself or getting rid of something that you need. So the setup on PrusaSlicer pretty much the same as always. There are a few new printer definitions in here. I was able to get the Artillery Genius up and running, and my print quality is pretty spectacular. So that's going to be it for this video, guys. I hope it was helpful to you. I'm looking forward to the full release of PrusaSlicer 2.4, and there are some new additions in here that are really handy. And it's important to note we didn't go over everything. There are some new mesh fixing tools and things like that that are pretty easy to access as well. And I'm not sure if this is the final edition set before. I mean, they might add something else in the beta before they do the final release, and they'll probably change a few things and take out a couple of bugs. But I love the new tools in this version, and I'm definitely recommending PrusaSlicer from now on. I am a big Cura fan for sure, but it seems like PrusaSlicer is going in the right direction with a lot of these upgrades, and it's nice to see them working together. You know, I jump back and forth. PrusaSlicer is one of those things where you can get a lot more settings out of it, but you have to be a lot more particular about making sure each setting is set right each time, or that you're in the right filament, or you're in the right printer, because mistakes happen pretty easily here with all of the tons of settings they have. You can see if I go to expert mode, there's quite a bit of stuff. So we can click the settings. You can see all of these parameters in here. So if you're new to PrusaSlicer, definitely start off in simple mode and get used to it. But if you are a little bit more advanced and you like more settings than you can get from your Cura slicer, definitely check out advanced and expert mode in PrusaSlicer. You won't be disappointed. It is very well put together, and there's a lot of stuff that can give you a really good print if you know what setting to change. So we'll see you in the next one, guys. Don't forget to leave a like and hit that subscribe button.
Stick around, guys. I got another YouTube recommended video for you right here. And if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out. Today on Cura Questions on the Technivorous channel, we are answering your questions about how to get more speed out of your Cura settings. So stick around and let's jump right into it. And I am back with another question. Today's question is from Catherine R. Rosa. She says, "Thank you for the information. I just downloaded the new Cura and I have a question. I am new to 3D printer and I purchased a Creality CR10 Smart. I don't actually know how to set up my Cura to do prints, and I've been using CR10S, and oh my god, the prints take so long, 20 hours and more. Would you be able to help me out?" Well, have no fear. I am here to show you some tips and tricks for settings that will make your prints go faster. Now, let's jump over to Cura and we will take a look at those directly. I'm going to go ahead and slice with my generic settings here. This is my standard profile. Now, this profile does work with pretty much all Creality machines. It is my Ender 3 profile. You can find a download link for it around here somewhere. I would recommend giving that a try. You can see I'm printing this pawn in around 41 minutes. Now, what can we do to make that print faster or slower? So let's see. First thing that comes to mind is the layer height. So let's take this, we'll take this up to 3.3, and we'll slice again. Our time should be significantly faster, and I'll explain this to you why this isn't really recommended. So 24 minutes, we've cut it about in half by doubling our layer height. That means we're printing the model twice as fast, but it also means that our layers are going to be more visible. Now, maybe that's not a big deal to you, maybe it's just a prototype, but if this is going to be a finished model, that is going to require more sanding to smooth it out and get it even. So generally leaving that below
0.16 is where you want to be. You can go a little higher than that. If I take this down to, let's just even do 0.08, I will have a really fine model. The layer lines will be barely visible, but it will take twice as long to print because I'm printing at half the layer height. So layer height is very important in determining how fast your model prints. You can see we're at 1 hour and 15 minutes, so it's added another half hour. I'm going to take that back to 0.16 because that's generally the range I'm in when I do my printing. And let's examine a few other things. Now, a lot of this here is going to be determined by your speeds down here. You can alter these numbers. You can see this printer is printing at 115 millimeters a second, which is the regular speed, but you can see it's really only doing the infill at that speed. Walls are done at about half of that, as well as the supports, and then it's traveling at max travel speed. So you can alter these. However, your walls, you're going to want to be going quite a bit slower than your infill, because that is going to be the visible part of your model, and you're going to want to be able to see nice finishes there and not any burring or zitting or anything like that. So that is also going to determine what the difference, what this can do for your speed. So if I have faster wall speed, adding walls will make my model print faster. Generally, that's not the case. Generally, your infill prints faster, so the less walls you have, the better. It'll increase your print speed. However, you don't want to go below a certain amount of walls in your shell, because anything below 3, I tend to find that the infill pattern shows through on the outside, and that is undesirable. So 3 is going to be pretty much the lowest you want to go standard, and that will get you pretty much the fastest print that you can get. Now, it's also important to note there are a few things about temperature here, depending on which filament you're using, that can be used to your advantage. Some filaments print a little faster at higher temperatures. It's just one of the things you're going to have to test per individual filament, but I wouldn't recommend playing around with the temperature and speed too much, because they're designed to be printed in a certain range, and that's generally listed on the label as well. A couple other things. Enable retraction. I do have retraction turned on. That retracts the filament. That takes time. You're generally going to want to leave that on, or you end up with blobbing and stringing. However, depending on your machine, you should be able to adjust this distance here. Now, I believe if you're using a CR10, you should have the same hot end as an Ender 3, in which case you're going to want 2.5 or 3.5 right here. And retraction speed is exactly what it says it is. And basically, the only thing in here that you can really do to save print time is this part right here. If this is checked, it's going to calculate a path going around your models to make sure that the nozzle doesn't bump into the top of the model, and that can add a lot of print time, especially if you're doing support and things like that. So turning this off will also increase your speed. Now, all of this being said, there is a trade-off when using speed and increasing speed and using these settings, because obviously with more speed, generally the model is going to get lower and lower in quality. However, there is a fine balance between printing a model at a decent speed and still getting something that is a nice object in the end and not hanging over with stringing and blobbing and things like that. So the most important thing is to test and test again, dial in your settings, and then once you have those settings, make sure that you're aware of what exactly they are, because if the avoid printing parts while traveling is causing you a lot of time, and it's also causing you problems turning it off because you're bumping into parts, that's something that you have to decide for yourself. What's more important, the speed or the quality of the print without damage or the risk of losing the part? Because, I mean, if you're printing something for 20 hours and you're 19 hours in and it breaks, you've wasted those 19 hours. If you're printing something that takes 24 hours and it adds those 4 hours, but you're saving yourself the stress of worrying whether or not it's going to knock into a piece of your model or remove it from the build plate and waste the entire time up until this point. So it's a fine line to walk and something you kind of have to decide for yourself. But other than that, I hope these tips were helpful, and we'll see you in the next video, guys. Don't forget to leave a like and hit that subscribe button. We do Cura questions all the time, and I'm happy to do them. So if you have any questions, leave them in the comments down below, and we'll see you in the next one. Stick around, guys. I got another YouTube recommended video for you right here, and if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out. Hey folks, Technivorous here, and it's been a few versions since I did one of these, so I figured it was time for an updated and in-depth tutorial on PrusaSlicer. If you're new to Cura and 3D printing, you're in the right place. I'm going to show you everything from how to navigate the slicing software to how to get that print to come out just right, and what settings you need to keep an eye on. Before we start though, I wanted to let you know I have a ton of Cura content here on my channel, including full playlists on individual settings, and a playlist where I specifically answer user questions left in my video comments. So stick around to the end and I'll put up a link, and if you have any questions about Cura, leave them in the comments of this video and I will probably make a video just for you. Be sure to leave a like and hit subscribe while you're here. So let's start with the basics. You're new to Cura, you know you need a slicer because you've just purchased a 3D printer, and odds are pretty good that Cura is the one that was included on the disk that came with your machine. That's not necessarily always the case, and if it's not, there are ways to add your own printer to Cura. So the first thing we're going to do to get you set up is make sure that you have a proper printing profile. I'm going to be adding another Ender 3. You can see I've done this a couple times before. The reason I'm doing that is because it is a very common printer and it is the one that I get asked about the most. So let's go here. You probably won't have these selections here. The first thing we're going to do is simply click on Add Printer. Now when you fire up Cura for the first time, you're going to be presented with a menu like this. So you might not even get the option to click this, but what we're going to do is click Add Non-Networked Printer. If you want to add one that's plugged into your machine, you'll click the other button. You just have to make sure that it's set up and you have the drivers installed. So this is a little bit easier though, since most of these end up having the same settings. You just simply scroll down, find your manufacturer. In our case it's Creality, and we are going to add, let's do an Ender 3 Pro. Let's go Add, and we're going to get a couple of options popping up for things like start and end G-code, which you'll see down here. These are pretty good right off the bat for the profiles that are listed. If you don't find your machine in there, you can add a custom printer, and in that case you'll want to do some research and find good start and end G-code for your machine, and you'll have to plug that in yourself. But for most market printers it is readily available, and you can go ahead and just hit next in this box, and we're going to do that now. And as you can see, we now have our build plate. You also have a couple of options up here. So let's take a look around the software interface now that we're actually able and available to interact. What we're going to see is our selected printer and then our selected material. This isn't necessarily important. You never have to change this if you don't want to. It's just one of those things where you can set presets if you're using the same thing and you'd rather change your temperature by selecting a different plastic and not mess with all your settings. So we're going to skip over that for just right now, and we're going to go to this because this is the meat of our slicer. This is going to determine everything. Yours should look like this actually. It's going to determine everything that our slicer does in order to turn the model, which we're going to import in just a minute, into G-code. Now, a little bit about G-code. It is simply machine code that is broken down into commands, basically telling the machine where to start, where to end, how much to extrude, things like that. So what we're going to do is we're going to take a three-dimensional model. This machine is going, or this software, excuse me, is going to slice that model into layers. That layer is going to depend on how many layers is going to depend on our layer height. So I don't want to overwhelm you. We'll get into that in just a minute, and it'll be a little bit easier to describe. But basically, I just wanted to tell you that because that's why they call it a slicer. Let's go grab some 3D objects. And what do we have in here? Oh, I think I opened a new Cura. That's all right. We'll drag this one into the window because it's going to take forever for that to open up. So here we have a coin I made. And you can simply drag and drop your STLs or 3MF files in here, or you can click this button here. This will allow you to load something as well. I have a bunch of different items. This is your layer height. So the smaller the layer height, the finer the details, and the less cleanup work you're going to have, but also the longer it's going to take. So you figure the whole height of the model is divided whatever this layer height is
and that's how many layers you're going to have. So the smaller the layer height, the more layers, and it has to do each layer individually. So this is going to be your second setting. This is your infill. Somewhere between 15 and 20 is what they consider standard, although there are a lot of different settings for infill, including different patterns and things like that. When we talk about support, support is going to be what builds up under big flat areas of your model to keep it from drooping over and ensure that it retains its shape. And if you look at this model here, you can see that all of this red area here is not quite on the build plate, which means it's going to need something underneath it in order to print that flat. So when I slice this with support, it is going to generate a certain structure down here. The structure for support is also variable depending on what you select. In most cases, I tend to go with tree support, but I'm not sure what's selected in here right now. The next thing in the simple menu here is adhesion, okay? So adhesion is basically how much you want your model to stick to the bed. And on a round object like this, generally, I wouldn't need much adhesion, so I could go with something like a skirt or a brim. But on large flat models with corners can tend to lift sometimes, so I use rafts as well. And we'll get into a little bit more about what each of those adhesion types are. But let me go ahead and slice this with our basic settings here. You can see I have 0.2 selected. That is a pretty high layer height. 0.16 is probably my average, but this should give us a much faster print. So if you're just prototyping and you need a rough copy, increase that layer height to get your time down. And as you can see, it's saying 5 hours and 7 minutes. So a little bit more about actual slicing. Let's take a look at preview mode, which we can do now that we've sliced our object. And if I zoom in real closely here, you can see these layer lines. So if you're staring at your computer getting frustrated because you can't seem to manipulate it in the right way, let's go over the navigation real quick because I kind of skipped past that. So in order to grab the screen and pan, I am right-clicking and holding my mouse. You can zoom in and out with the wheel, and you can also rotate what's known as a brim. And a brim is attached to the outside of your model in order to ensure that none of the parts lift up. It's a little bit excessive on a circle because, like I said, lifting normally happens on corners, and with PLA it shouldn't be a problem if you have your bed level anyway. Anyway, I digress. The inside is the beginning of our support structure, and you can see these lines, this grid pattern. Those are going to build all the way up until just underneath the model, and then the model is going to be built on top of it. That way it's not trying to print a large flat surface over thin air. And you'd be surprised, actually, that's called bridging, and you'd be surprised how good printers are at just printing with nothing underneath them sometimes. Some of them do a really amazing job. So as we scroll up and we begin to see these interior lines, these are our infill lines, and it's set to a triangular pattern right now. You can change that. Since it ends up on the inside of the model, it doesn't really matter to me what it looks like. So you can select whatever one you want, and there are a ton of different settings that you can use, such as gradual infill to save yourself plastic and time and things like that. So now that we have the model completely sliced, let's go down to the bottom layer here, and we are going to rewind it back through the actual G-code. So when I click on this, you'll see the nozzle head appear there, and if I rewind it all the way back to the beginning, this will show you exactly how it's going to tell your first layer. It's simulating your printer printing out the first layers. This is exactly the pattern it should go in, and it'll go just like this, around and around and around until it starts building up the inside, and then it'll do the walls and the bottom surface. So the yellow, green, and red here, that is your actual model. So quick note though, I'm noticing that I have one line of red and one line of green. That infill pattern that we talked about can sometimes show through to the outside of your model. So what I'm going to do is increase the walls, and you should see more red here when I'm done. In order to do that, I need to get to the more in-depth settings, and you do that simply by clicking custom right here. Now don't get overwhelmed, there are a lot of settings in here, and right now is a good time to point out that, like I said, I have a Cura settings in 5 minutes or less set video playlist, and each of those videos goes over each of these settings and what they do in 5 minutes or less, explaining them. So I'll put a card for that in the corner up here. You should see it popping up, and you'll be able to click on that and jump right over and explore any of these other settings you wanted to explore. For right now, we found the setting I was talking about, and that's a wall line count. 2 is really low, so generally I'm going to want 3, preferably 4 or 5. 4 is probably my average. Now that we've changed a setting in here, it's going to have to recalculate our model because it's going to change the G code to adapt to account for our settings. So let's go ahead and hit slice again. And when we go back down into the model after it's completely done slicing, you should see more red lines comprising circles around the exterior of the model in order to illustrate that there are more walls. So it's processing, and there we go. Okay, yeah, so my mistake, the red is just the outer wall. These green ones are the additional walls. So we went from 1 green and 1 red to 3 green lines and 1 red line. And that means that our wall is thicker, and there's pretty much no way that this infill is now going to show through the model on the outside. And what I mean by that is sometimes you get this pattern that's like a crazy square or hexagonal pattern depending on what infill you use, and it's not necessarily a good thing. So this is the in-depth custom settings menu. As I said, there's a ton of stuff in here, and we can actually break this down for you just quickly, and you won't have to go over that settings video. But let's take a look at all of these major settings, and I'll tell you what they mean for your print. So basically, quality is going to contain things like your line height and nozzle width. So this is going to be your initial layer height, your layer height, things like that. That is going to determine how high these lines are, how thick each layer is. And like I said, the thinner, the better, because you have less finishing work. They won't be as noticeable. You won't need to sand them as much. And the bigger they are, the higher that number, the bigger those lines are. It's going to print really, really fast, but it's not going to be as neat and clean as if you had used a smaller layer height. So that's why they refer to that as quality. Walls is a setting you should be somewhat familiar with because I just explained it to you pretty well. And as you can see, there are a ton of settings in here, and they're all worth a look. I highly recommend checking out horizontal expansion and whole horizontal expansion if you're making parts that fit together. And then you have top and bottom. That's going to be your flat surfaces on the top and bottom of the model. How many layers do you want that to be? Again, if you're seeing infill show through on the top or bottom of your model, that's not going to be the walls, that's going to be this setting right here. So you can increase that in the same way. Here you have infill. We're not going to go over all of these, but as you can see, there are a ton of different infill patterns. If I select one of those, it's going to make me slice again, and I don't want to do that. So we're going to go ahead and close that. Material is going to be where you set your temperature. Now, this is why I said you can pretty much disregard that material setting that shows up in here under prepare. And that's because you're going to set your temperature and print settings here. So most new users start with PLA. I hope that that's what you have, because I'm going to show you some quick settings to get a nice print off the Ender 3 with PLA. And we're going to go over it real quickly. So basically, PLA is going to print well from a range of around 205 to 230. In most cases, 205 is where I would start because it's easy to burn, and you don't want to burn it because that'll cause clogs in the end of your hot end in the long run. So I've increased the printing temperature, and the build plate temperature for PLA, you really don't need to worry about this. I'm going to leave it at 60 because the warmth does help a little bit with adhesion, but PLA pretty much sticks if you have the bed level no matter what. So I'm going to go ahead and skip all of these other settings right in here. Those are the main two that I need to deal with in order to deal with the material. I do, however, want to go down and check out speed and make sure that we're not printing too fast. Now, 50 millimeters per second is pretty slow for the Ender 3 Pro. I've seen it go at 150, but the quality starts to go down after about 75 millimeters per second. So if you take that up, you should still get a decent model. If you're starting to get a little too many flaws, go ahead and reduce that down a little bit, but you should be fine anywhere in that range. And then we are going to go to travel. This is going to have a retraction distance. So the retraction distance on the Ender 3 Pro, for me, a 4.5 works really, really well, and that should work for you as well. I do want to mention I do have a profile for the Ender 3 that you can just download and plug in if you don't feel like doing all these settings, but I just kind of wanted to explain to you what these settings do and why we use them. So the next thing is going to be cooling. And with PLA, you want your cooling on, and you want it on 100%. Different polymers and plastics are going to require different settings, and some, such as ABS, you're not going to have the fan on at all. Some, such as PETG, you're going to reduce that fan speed to about 20%. If you're looking for more on fan speed settings and what to use with your particular plastic, I do have some videos on my channel about that as well. So make sure you subscribe and kind of dig around and see if you can find anything that you find interesting over there as well. Support, we are using on this model, and it is turned on. The structure is normal. As I mentioned earlier, there is something in here called tree support, and that is what I normally use because it tends to save a lot of plastic and it just kind of looks cool. So definitely recommend checking that out. The only other thing in here that's really important to look at is your support overhang angle. Now this one is set to 45 degrees. 45 degrees is pretty conservative, to be honest. The Ender can print pretty much up to 55 degrees without any drooping. So I could get another 10 degrees of tilt, which would require less support and also less calculation time for slicing the model. However, in order to find your proper support overhang angle, I highly suggest you print an overhang tower. Now these are pre-made models with selected angles modeled into them, and you can print them, and if you examine them, you can see exactly where your model starts to droop without support, and then you can type in the proper value here. We're going to go ahead and leave it at 45% since anything supported on this model is already at a 90-degree angle, so raising that for this purpose isn't really going to give me a change. Oh, I didn't mean to turn it off. I meant to close the tab. There we go. And then you have your build plate adhesion. As I said, a brim is a little excessive. So since I've showed you that already, let's show you the skirt. Now, a skirt is going to be exactly like a brim, except it's not actually going to attach to our model. Now, what it does is creates a purge line going around the outline of the object similar to the brim, and allows us to ensure that the filament is flowing nicely through our nozzle and we're getting a nice squish on the first layer, that everything's coming out nicely before it then skips a beat and moves on to the interior and starting to print the model. So we should get a nice circular outline in this case, maybe with a couple of flares because of the ridges on this coin. And this is probably my preferred method of doing adhesion because it just kind of makes sure, like I said, that everything's running smoothly, but then you don't have anything to cut off your model at the end. Of course, a raft is slightly superior in my opinion, but it does use a lot more plastic. So we are looking here at our skirt. We've set it to 3 lines, and that's what we got. And then it's going to stop and go in and start printing our model. So that's exactly what we want. We'll go ahead and close that. We're not going to touch on dual extrusion because the Ender 3 is not a dual extruding printer. However, if you have more than one nozzle, you will need to look into these settings. So I highly suggest checking out my Cura settings in 5 minutes or less playlist. Special modes, we don't really need to look at either, although I will tell you there are some cool things in here. So let's take a peek. For instance, mold and spiralize. Now this is your vase mode, and this is for making an inverted object. So it'll make the opposite, the negative of your item, allowing you to make a mold that you can make replicas of, basically. And then you have print sequence. This is all at once. This is how this is set. If you want to print things one at a time, you can change that. Not really a great idea on this machine because the height isn't really what it needs to be for doing that. There are some experimental modes. I highly recommend not playing around with these until you are familiar with the rest of them. And if you're seeing settings in your settings that you don't want, you can disable them. And if you're seeing settings in my settings that you don't have, the way to get them is to simply type in here, and it will show all of the settings with line involved. So if you're not getting what you want from selecting that, we can go to Manage Settings Visibility, and you can turn all of these options on or off. So I have pretty much everything on. I don't use most of this, but it is nice to have access to it and see what you can and can't change. So if there's something that you're not seeing, you go ahead and type it in here, and it'll give you all the settings with that topic for you to access. Once you click it and turn the checkbox on, it's going to show up in here as well. So now that we have our sliced model, all that you need to do if your printer is not hooked up is click Save to Disk. You're going to want to make sure that your USB stick with your micro SD card is inserted in the computer and that you are saving it to that disk. What will come out is what's known as an STL file, as I mentioned, or excuse me, we're bringing in STLs. What's going to come out is a G-code file. That's going to be a series of numbers and commands that your printer is going to run off of, basically. So once you insert that SD card into your printer, you can simply click Print and select that file, and then the printer should start up. Now, this is the part where the slicer has nothing to do with it. Once your file is sliced, you're going to need to make sure that you know what you're doing printer-wise, and in order to do that, I have a playlist that I'll be putting up here that is basically me setting up and doing all of the different things you need to do to calibrate a printer on an Ender 3 type printer. Just so you can kind of see how to get your bed level, how to make sure everything is inserted properly and that everything is right. So we'll put that card up here, and that is going to be that. I'm going to cut this video short because now that you know how to import, slice, and export a model, you're pretty much ready to go. However, like I said, if you do have any questions, feel free to leave them down in the comments, and make sure you tag Cura question in there. So basically just type, hey, Cura question, and then follow it up with your question. That's how I search things, and I most likely will make you a video answering whatever question that you have. If you'd like to see the playlist I already have of all the questions I've answered already, I'll put that up in the corner as well. Make sure you check that out. There are some really, really common questions in there. I get asked a lot. So if you're new to Cura, I definitely think it is a very good resource for you to peek at and kind of see what might be daunting to you in the future before you run into those problems. So that's going to be it for this video, guys. As always, leave a like. Please, please, please leave a like. Share this video out to your friends in social media because I appreciate it. That's the best way to help other people find us on YouTube and use this as a resource. And make sure that you hit that subscribe button. I will see you in the next one. Technivorous out.
Hey folks, and welcome back to the Technivorous channel. Today we are looking at what infill is the fastest in Cura, so stay tuned. Alright, so today's question is which infill is going to give us the fastest print time. Now, a couple things to consider here for this process. We're going to be taking a look at the print times only, not actually printing them, and the print time does vary depending on your machine, and that's not going to be exact, but we can get a good idea of estimated print time here, and that's what we're going for. So we have this large cube shape that is actually a primitive that we've just added to the side of this box, and the reason for that is to get a large volume of area that we can actually test our infill in. So we're going to go in, we're going to slice it at the same density, that is, I think it's at 18%, yeah, 18%, and we're going to try every single one of these and compare the time and filament used. So filament should be pretty much exactly the same either way if it's getting that density correctly, but the time should vary slightly, and our goal is to see which one of these gives you the fastest print. So the first one we're going to do is grid. Let's grab it and slice it. So our first result is in, and the time for this giant box, 18% infill with the grid pattern, is going to be 13 hours and 11 minutes. So let's put the pattern and the time up on the screen there, and we'll go ahead and slice for the next one. So the next pattern here is going to be lines. We'll see if this goes any faster. Thankfully, this is a large square object. It's computing rather quickly, so I shouldn't have to keep jump cutting the video here. That one gave us a time of 13:21. I'm making a note of this so I can put that up on the screen as well. And 126 grams again. So The next pattern is triangles. Give it a second to slice here. So far the difference is about 10 minutes, and that's pretty negligible considering the fact that it's going to be slightly different when you actually print it than that as well. So here we have 13 hours and 10 minutes. So triangles seems to shave 1 minute off of our print time on this object. So 13, 10, and again 126 grams, which is, we were expecting those numbers to all line up. That makes sense. Let's try hexagon. The further we get down here, some of these might start taking a little bit longer to slice and process, but it shouldn't be too difficult, and it should still go pretty quickly. Next is trihexagon we're on here. And it is looking like this one is going to finish and give us a time of 13 hours 12 minutes. So that is the third quickest so far. And obviously we are at 126 grams again. So the accuracy of the infill percentage seems to be pretty dead on so far. Let's try the cubic method. Hit slice one more time. And that's going fairly quickly. 13 hours and 12 minutes. So the same as trihexagon. And the weight is exactly the same as expected, so no variation there. Let's try cubic subdivision. And I think that when we're done with this, we're going to get a little bit more complicated of an object that doesn't have such even edges, and we'll try this all again. And with cubic subdivision, it looks like we are saving quite a bit of time. This one is actually coming in at 12 hours and 43 minutes, making it our fastest so far. Oddly, it is also coming in at 117 grams. So using less filament with the cubic subdivision and also printing faster, that's an interesting observation. Let's go ahead and try octet. Slice that up. And we'll see what we get for a result. I wasn't expecting that from cubic subdivision. 13 hours, 16 minutes, so not bad, pretty much around our average here. And again using 126. So next on the list we have quarter cubic. Let's slice that up. Again, once we switch to a more complicated object, it's probably going to take longer to slice. 13, 15. And let's see the next one. Still 126 grams. Concentric. This should be interesting since it's just square shaped. And should actually be pretty quick. 12 hours, 7 minutes. So this one is our fastest so far. And it is using 121 grams. So that's interesting. It's very interesting. And for the next one, it's going to be zigzag. Let's go ahead and slice that. And we'll punch that up on the monitor here. See what it gives us for zigzag. 13, 14. And oof, we're using a hefty 131 grams there, so that one's actually taking longer and costing us more filament. That's an interesting observation as well. Let's take a look at cross. Cross is the one after zigzag here. We're just going in order. And let's see what we get for a result with this pattern. So far, by far, concentric is the fastest, which makes sense because it's not really having any travel moves. Oof, cross is taking 15 hours and 56 minutes. It is also using 123 grams, which is lower than our average, but variation there is strange to see. It means we're not getting the exact percentage that we're going for in relativity to the other infills, but that's not really a big deal. Let's check out Cross 3D. Very similar, but then again not to Cross. So Cross 3D. And man, I'm glad this is going so fast. Looks like 1525, so slightly faster than the other method, but not as fast as some of the others. We're using 120 grams, so again, even less, which is an interesting thing. Last one we're going to try here is gyroid. We're going to slice it on gyroid, and then we're going to try a few other things that we find interesting here. So let's let this process finish up, and we'll just kind of see where we're at here. Okay, gyroid is obviously taking the longest to calculate. I think that is probably pretty normal. It is a complicated pattern. It's interesting. It looks cool, but I could see it taking a while. So doesn't take as long to print though as some of the other patterns at 14 hours and 59 minutes. But it is using 127 grams, which makes it only one of 2 items using more than the regular amount of filament. So 127, slightly over average. Okay, so the next thing I wanted to do was go out and grab a better model here. Alright, now what we've done is brought in a slightly, well, a very much more complicated model. There's a lot less infill to fill here, and yet we're going to see how it calculates out all of this. We're going to test out the time difference between, I think, our fastest, which was concentric, so we'll try that first. Infill, go with concentric. We'll slice that and see what it's at on a complicated model. This is going to take slightly more slice time, so you may see a few more jump cuts here, but hey, we like to play around. I think after concentric we will test that against its slowest, which I believe was the cross mode at 1556. Now, the reason these tests are going to be slightly different in their results, obviously they're going to be way different in their print speed because they're completely different objects, but the reason you're going to get slightly different answers for which one is fastest is because of the shape of the object. Concentric prints really fast on a large flat object like that because, like I said, it doesn't have to travel. It just continues itself around in a singular pattern. Once you get to an object with a lot of jumping like this, there's really no advantage to concentric, so it's kind of mitigated. And I don't think that it will necessarily be slower than our slowest one, but it'll definitely be more comparable in speed to some of these other versions. So it is taking forever to slice. So how about that jump cut? Okay, so for our treble clef model in a concentric mode, we are looking at 50 grams of filament and 9 hours and 37 minutes. So before we jump over and compare that with the slowest, let's jump over and compare it to the next fastest. So concentric was followed the closest by 13 by zigzag here. Actually, let's do this. Let's try triangles because that one was actually faster. And insert another jump cut here. Ooh, and mysteriously, the triangle's just getting whooped here. And being left in the dust with time of 10:45 and using 54 grams. So, okay, so let's see the time difference between that and the slowest, which we decided was the cross pattern. So cross and slice. And for one last time, you are seeing pretty much a consistent scale here as far as the triangles and concentric both being pretty fast. There weren't any that ended up between them, just for the sake of rounding this out. Since triangles became slower than concentric, I want to try one of the other ones that was also slower than triangles, but fast near the speed of concentric, and see if one of the velocity's sake. The whole reason I made this video is because I'm constantly debating which of these I think would be faster in my head. But the fact of the matter is, it kind of turns out to be on a per model basis, and as you can see here, it depends on the shape of the model, and a lot of it has to do with how many gaps there are in the actual shell of the model itself. Say from here to here to here to here to here to here, because those are all travel moves, and travel moves take time, and they usually involve retraction, which takes time, and they usually involve priming after retraction, which takes time. So these are simple things that you wouldn't think would multiply out the time of your print speed, but they really do, and having the best infill pattern for the purpose is one of those things that you really want to try and nail. There you have it, 10 hours and 39 minutes. So that is definitive proof that the fastest isn't necessarily going to be the same for each model that you print. It's going to be different depending on the area and the separation in the model, as I said, between those travel moves. So 10 hours, 39 minutes for grid mode, which is, as you can see, a lot faster in cross mode, but also faster than triangles, which was one of the far quicker ones. And I'm very disappointed that that is how that came out. So it's just kind of weird to me that concentric is always the fastest. Then again, like I said, there is no travel move interior to the actual pattern itself, so this is going to give you the fastest infill in pretty much every case. So the definitive answer is concentric. Go with concentric. Let's try looking at cubic subdivision. I know we said we were done, but I want to see one more. We're going to look at cubic subdivision here, because that was really close. It was second to concentric, and I want to see if it's still in second place. So let's go ahead. We will do this one more time. And slice. Seems to be going pretty quick, and it's stalled out. I'll see you in a second. And there you have it. It's concentric for the win. When it comes to speed, concentric is the fastest infill pattern that you can get. Not only is it the fastest, but it is going to be the cheapest on infill in almost all cases. The Cross 3D case with the normal print was 1 gram cheaper on the filament, but then again, if you're going for a specific percentage of infill, the closer you can get to that percentage, the better, so that's not necessarily a good thing. This isn't really to say anything about the durability of pieces printed with particular infill. That is a whole different story for a whole different day. I suspect concentric infill in most cases of being slightly inferior or weaker than most other infills because they don't have any cross support. They basically just follow the object's shape. So if you have a large cylinder or tube, the interior infill is going to be simply a spiral around the inside, which would be easily crushable from pressure around the outside of the circles. So the thing to keep in mind here is what you're using it for. In most cases, if you're doing prototyping or rapid design, definitely go with concentric infill because it will shave time and plastic off of your print. That's going to be it for this one, guys. Technivorous. We'll see you in the next video. If you have any Cura questions, drop them in the comments below. Don't forget to leave a like on this video and smash that subscribe button so you can be subscribed to the channel. And we have the notification button as well. If you ring that, you'll get notified every time we post new videos. I do quite a few of these videos, and I have a different playlist called Cura Questions where I answer everybody's questions about Cura. If you'd like to know more, there is a card over there. Click on that and it'll bring you to the playlist. You'll be able to see all... Welcome back to another Cura Questions video. I am Technivorous. Today we're going to be discussing why Cura crashes when you try to load a file and what to do about it. Welcome, folks. I am Technivorous. We are back with another one of your Cura questions. Today's question is, why does Cura keep crashing when I try to load a model? Now, this is an error that has happened regularly since Cura 4.9, and it's actually a compatibility issue. So let's take a look on my desktop here. We have a couple of STLs. These two STLs are just basic STLs. This one here is super high in triangles. It is 136 megabytes compared to this little guy, which is 403 kilobytes. Doesn't matter the size, okay? These are displayed using Chittobox's thumbnail preview. Now, let's take a look at the Ultimaker Cura FAQ site. So they have a lot of questions coming in about this crash, and the answer was last updated on September 21st, 2021. Now, that is last month, and it seems like ever since 4.9, they've been having some compatibility issues with Chittobox. So it's not Chittobox itself, it tends to be that thumbnail preview mode, and since I use Chittobox for my resin printers in MSLA mode, I kind of need it and I can't uninstall it like they're suggesting for option 1. So instead, I went with this option, which was uninstalling the thumbnail preview. Now, since I've done this, it has improved the crash rate of Cura. I am not crashing when bringing in models now. I'm not crashing when bringing in multiple models. So this is something that's kind of distressing to see. Really irritating that a simple outside program could cause Cura to crash, and if you don't know about it, you're going to rack your brains trying to figure it out, and probably several a day. Sometimes I make a couple a week. It just depends on how many questions I have coming in on the software. So if you need to know something, are curious about something, would like a demonstration, or just have a question or some ideas that maybe I haven't thought of and shown to the community yet, feel free to leave those down in the comments. I appreciate every one you leave, and if you leave me a question, I might make a dedicated video just for you. That's going to be it for this one, guys. Technivorous out.
Stick around, guys. I got another YouTube recommended video for you right here. And if you haven't already, subscribe. Make sure that you smash that like button. We'll see you in the next one. Technivorous out.
one, you can actually type in primitive models using your own code and build models basically just all out of code, which is really, really cool. I do have some videos on IceSL around my channel here, so if you're interested in seeing more on this particular slicer, definitely search my channel for those. You'll find some cool stuff. And on that note, we are going to be going through pretty much all of these slicers in depth in their own video. I have done all of them before, but that was a couple versions ago for most of them. So let's go back to our main list, and we're going to skip talking about Simplify 3D because it's paid, and that's not what this is about, and SelfCAD as well. We are going to touch on KissSlicer real quick. It is paid with a free option. The free option is not as robust as the paid option, but KissSlicer is intense. KISS here stands for Keep It Simple Stupid, which the slicer really is not. It can be a little complicated at times, but for dialing in little minute details that you can't get anywhere else, KissSlicer is simply the best slicer for tuning your printer and getting exactly perfectly defined prints. Now, that's based on me using Marlin, not using Clipper or any of those other softwares. It's just the most common printer, the most common software. If you use this on an Ender 3 and you dial the settings in right, you're going to get beauty every time. Okay? And that's even with the free option. I personally have not tried the paid option, but I did get some really nice prints out of the free version. So the next one is Tinkering Suite. That one's free. I have not tried this one. I think I'm going to grab it and check it out. Although, if I recall, maybe I did touch on it once in the past, and it was really, really simple. So that one is available as well, and you can get it at their download page. So, by the way, I will be pasting this for the main bulk of these links, and then these other ones I'll have individually. I do recommend checking these out. They are really good products. Then you have PrusaSlicer. PrusaSlicer can be found on Prusa's page. PrusaSlicer is an amazing slicer, especially if you have a Prusa machine. And the cool thing about PrusaSlicer is if you're into their machines and you have an FDM and an MSLA machine, it can slice for both of them in the same software, which is really, really cool. We can talk about Octoprint for just a second. It is completely free. If you're not a techie person, you're not into Raspberry Pis, it can be a little bit intricate to set up. It's not that difficult, and a lot of people do it. It is very, very common, but it is a little bit more in-depth to get Octoprint running on your machine. And then you have Repeater. Now, Repeater Host is technically not a slicer. If you're curious about testing multiple slicers instead of just downloading all of them, what I would do is download Repeater, because there are options to use the slicing engine from different slicers. So basically, it is a host engine that will allow you to set your settings, and then you can pick, say, PrusaSlicer's engine, or you can pick Cura's engine, and you can slice it with either of those. So the settings aren't quite as intuitive as those two programs, but that's because this program is built to work with other engines for slicing other than just one that's built into it. So really, really cool software. I would check that out as well. And like I said, you'd be hard pressed to find a slicer that I haven't tried. I have tried Simplified 3D, even the paid version. I was not really impressed with it. And I can tell you at the end of this video that any one of these free slicers are just as good, if not better, than the Simplify 3D slicer. And I know that hurts them to hear me say, but it's a fact. It's just a waste of money when there's so many other good free products that you can use. I highly recommend sharing this out with everybody. Hit that like button so YouTube will share it as well. And I'd appreciate it if you hit the subscribe button. That way you get notified when I post videos on each of these slicers, and you won't have to download them yourself. You can just kind of check it out and see which one looks the best for you. That's going to be it for this video, guys. I appreciate you as always. It's been a pretty good year so far. I've been laying a little bit low, but you're going to see me getting back into doing videos a lot more often now that I have a little more free time on my hands. Back with another Cura Questions video. Today's topic: what is the best infill for your 3D prints? Stick around because it's going to get through the triangles. It's just what I happen to switch to when I slice this. The thing we're going to talk about is benefits to using different infills. Okay, different infills don't really have different purposes structurally. Now, there's some debate as to which infill is the strongest if you're trying to make a part that is the strongest part you can make. And the answer to that is always to print it at about 98% and make it almost completely solid. Now, you don't want to do 100%. Most cases, that will over extrude. But if you're going for a solid part, just print it solid. It doesn't matter what infill you pick. It's not going to be a very big strength differences. And there are videos on this that will explain to you exactly why that is. But today, I do want to touch on a few other things. There are reasons, obviously, to print your objects with infill instead of using all the filament it would take to fill the interior cavity of the whole object. Okay? So what are the benefits to using different ones if you have to use them? So obviously, we're going to be using infill.